Hello, my name is Jiarui at McGill University, supervised by Professor Yao Fiona Zhao. In this video, I'm going to talk about FairGen, fairness and uncertainty-aware data generation for data-driven design based on active learning. Due to the time limitation, I am only giving a brief introduction of this work. In traditional data-driven design, we first parameterize the design, then sample designs from the shape space. After that, we conduct simulation to find the properties of the designs. This dataset seems quite fair from the shape space. However, if we take a look at the property space, we will have a different conclusion. Typically, in the property space of a design dataset, there are unexplored regions, void regions, and intensively sampled regions. This is referred to as data imbalance. So we developed this FairGen to mitigate data imbalance in the property space by filling the voids and exploring the property space. But if these three are the new properties being populated, the data coverage of this dataset is not increased at all. Thus, we developed this coverage module that evaluates the data coverage of the dataset to conduct adaptive sampling and select the desirable properties. Now we know what properties we want. We need to find the shapes that can provide those properties. Thus, we trained a generative model based on the existing dataset to estimate the shapes for each desirable property. However, we often find that there are some shapes that cannot provide the desirable properties they're supposed to provide. This is because this property does not have any data point nearby. This dataset does not contain relevant knowledge to this property, and thus the machine learning model trained based on this dataset is uncertain about making such a prediction. We have developed an uncertainty module to measure the predictive uncertainty of the generative model to avoid selecting those properties. And we can do this iteratively to mitigate data imbalance. To build the coverage module, we introduced to this domain the data coverage notion, where we can define a coverage radius rho and a coverage order k, compared with commonly used diversity metrics based on pairwise distance matrices. Data coverage can deal with one-to-many relationships. It can also quantify and visualize representation bias. We used Voronoi diagram to compute data coverage and reduce the computational complexity. The coverage score is the area or volume covered by the dataset. We implemented deep ensemble to build the uncertainty module. This is a simple example of how it works. Deep ensemble trains multiple models using the same dataset. If the predictions of the models are close to each other with a small variance, it means that models are certain about such a prediction. If the predictions are far away from each other, it indicates that the models are uncertain about making such a prediction. Using this method, we can build an uncertainty module visualized by this uncertainty map. We have large uncertainty scores at the regions where we have no data, and we have small uncertainty score at the regions where we have a lot of data. This way, we can avoid sampling from the uncertain regions. Here's the result from our case study. As you can see, the coverage score of FairGen had the fastest increase as the number of sample increases, compared with other sampling methods. Here's the scatter plot of different datasets sampled using different methods. It indicates that FairGen has a better space exploration effect than the others. Thank you so much for your attention. For more information, please refer to the paper. If you have any questions, feel free to contact the authors.